Hi everyone. In this video, we will explore how artificial intelligence is transforming structural health monitoring through yearly damage reduction, continuous monitoring, and smarter maintenance planning. What if structural problems could be identified before the failure occurs? So this is possible through AI in structural health monitoring. So first we'll see what is structural health monitoring. Structural health monitoring is a process of assessing structural condition that involves collection and analysis of data for assessing structural performance. And structural health monitoring is also used to assess the performance of building, and it is mainly used to detect the yearly damages and prevents its failure. Many infrastructure projects involving bridges, high-rise buildings, dams are assessed through structural health monitoring. So process involves collection of data through the sensors, then data processing or data acquisition, and finally data analysis. From the data analysis, we will be able to assess what is the condition of the existing structure. So on the right side, the summary of what is structural health monitoring is explained through the image, where we can see the availability of sensors and supernode. So sensors are used to collect the data, and supernode, it is used to process the data, and it is used to disseminate the information regarding the health condition of the structure. And from the data taken from the supernode will be used for automatic model identification, and it will be helpful for damage reduction and life estimation of the existing structure. So why we need to know do structural health monitoring? So structural health monitoring is required to ensure structural safety during service life, and we can detect damage, cracks or deterioration at the earlier stages, and we can also predict what is the remaining useful life of the structure and reduce the failure before it occurs, and we can reduce the unexpected failures and provide input for maintenance planning and retrofitting. So how this can be done? So this structural health monitoring can be done as a major 4-step. First one is fixing of sensors, where it is mainly used to collect the data related to strain, acceleration, vibration and temperature. And data acquisition systems are used for storing and transmitting the signals, and data processing or analysis is done to extract only the useful features which are required for monitoring the health condition of structure. And finally, based on the data collected and based on the analysis of data, the decision support will be done for damage identification, and the maintenance action required will be suggested based on the output which is being obtained from the data processing and analysis. So next we'll see what are the different systems which are involved in structural health monitoring. The first system is sensing system, and sensing system involves sensors. So sensors are used to measure the responses of the structure in the form of acceleration, strain, displacement, temperature, etc. So whenever the load is applied to the structure undergoes deformation, and that deformation is measured in the form of a strain and displacement, as an example which is given here. And whenever there is lateral load applied in the structure, acceleration can be measured, and that acceleration data will be helpful to study the behavior of the structure under lateral load. And we need to collect even other environment data like temperature and humidity, which is also essential to assess the health condition of the structure. And after finding the responses of the structure to the loading, we will be able to capture what is the health condition of the structure. So mainly accelerometers are used to measure vibration or acceleration, and strain gauges are used to measure the deformation, and the displacement can be measured through LVDTs, and the displacement can be determined. So after finding all the required data, the second step includes data acquisition and transmission systems. So in order to collect raw data from multiple sensors and transmits for processing, we need to have data acquisition and transmission system. And this involves data collection from the sensor. And the data collection can be done through data loggers or microcontrollers which are provided at each sensor node. And wireless communication modules can also be used. And as I discussed before, super nodes which are acting as a gateways are also used for aggregating the data from several nodes and from which the further processing of data will be carried out. And the next step involves data processing and feature extraction. And the system involved here are used to convert the raw signal data which is collected from the sensors into the meaningful information. And this main step is done in order to reduce the noise and extract the damage sensitive features. So during the process of data collection, there is a chance of recording unwanted data in the form of the noise. So those noise has to be reduced so that the condition of the structure can be exactly determined. So the various techniques which are involved in order to do data processing and feature extraction or signal processing and model analysis. Mainly it is done to identify the natural frequencies and mode shapes under the application of lateral load. And AI and machine learning algorithms are mainly used in this step of data processing and feature extraction. Finally, we need to identify what is the extent of damage, and we need to know where the damage has occurred and what is the severity or extent of damage. Based on the damage assessment, we will be able to assess what is the remaining useful life of the existing structure. And we can see a system which is taken from the published article, that there are sensors located at different parts of the building. So the red dot indicates the sensors fixed at the different parts of the building, and through the sensors acceleration data is collected, and acceleration data is collected through accelerometer under the action of wind or earthquake load. Acceleration data is collected and cumulative absolute velocity is being measured, and this data which is obtained from the sensor is fed into the ANN architecture, which involves damage features which is taken from the building, and it will be processed through hidden layers, and the output is obtained. So the output obtained here shows the damage reduction as part of the building which is being damaged or undamaged, and part of the building which is being damaged as major, moderate, severe, minor and undamaged condition. So here we can see that there are two types of learning algorithm which has been adopted. One is unsupervised algorithm and supervised algorithm. In next video, I'll be detailing explaining about what is unsupervised algorithm and what is supervised algorithm. So these algorithm is finally used to assess what is the condition of the structure. So this is shown as an example of how the AI can be used to assess the damage condition of the structure. Next, we'll see how the damage reduction is done using AI techniques. So the AI techniques which are generally available is being listed out here. So different AI models are used in structural health monitoring for prediction, classification, data generation and anomaly detection. And the models are selected based on the objective required, such as prediction, classification or abnormality detection. So these techniques can analyze large volumes of data which has been given as input, and it is found to be faster than the traditional manual methods. So AI can also help to identify hidden damage patterns that may not be visible during routine inspection. So use of this intelligent algorithm supports continuous real-time monitoring of bridges and buildings. So as a result, maintenance can be planned earlier, reducing repair cost and improving structural safety. So now we'll see the techniques. First one is artificial neural network or recurrent neural network. So this is mainly used for studying the nonlinear behavior of the structure, and it can also predict future vibration response under the action of dynamic loading. And second one which is given here is support vector machine or decision trees, and this type of algorithm is mainly used to classify whether the part of the structure is damaged or undamaged. And we can also generate the data when the real-time data is limited. We can use the algorithm which involves GAN, that is generative adversarial network, and this type of algorithm is used to generate sensor data when the sufficient data is not available for further prediction or processing. And last one is autoencoders, and this is mainly used to detect anomalies in the data which is given in the structure. After assessing the damage condition of the structure and finding the severity of the damage, the remaining useful life of the structure will be predicted based on the learning degradation trends from the historical data. As an example, we can see that RNN can forecast how the cracks grow under the repeated loads. So by using this AI technique, we'll be able to schedule the predictive maintenance instead of going for reactive repair, that is after the occurrence of damage or crack. And all the steps which has been included till now will be helpful for taking the decision. And the decision support system involves integrating AI with the multi-source data like with sensor, environment, and maintenance history. And for the decision support system, we can use reinforcement learning, where reinforcement learning can be recommended for optimal repair or retrofit strategies. So these are the various steps where the AI is used in structural health monitoring. So first, as a first step, we need to know where the sensors has to be fixed. So that sensor placement optimization can be done with the help of AI techniques. And second step, which involves data processing and feature extraction. So for automated feature extraction, we can use the application of AI. Then as discussed in damage reduction and diagnostics, AI-based damage reduction will be helpful to identify the severity of the damage and extent of the damage. And based on the damage identification, we need to estimate what is the life of the structure. And remaining useful life prediction can also be done using AI technique. And finally, AI-driven maintenance planning can be done through application of AI in decision support system. So we can see that the sensors plus AI will act as a synergy in a structural health monitoring, where the sensor collects data and pre-processing of data can be done, and AI filters will extract the useful signal, and that extracted data will be used to interpret the pattern, and from the pattern identification we will be able to assess what is the health condition of the structure. And earlier, these are the various applications where the AI can be used, like yearly crack detection, predictive maintenance, real-time safety decision. So before the cracks are visible, we will be able to identify the damage by the application of AI techniques, where we are shifting from reactive to the proactive maintenance. So we'll see now how the AI is useful for data pre-processing. And this data pre-processing is an important step for structural health monitoring. As we see that sensors generate larger amount of data, and large volumes of raw data will be available, including strain, vibration, displacement, and temperature. And these raw data can also contain noise, or some missing values can be done due to like sensor not working due to some condition, and some redundancy may be available in the data. So we need to process the data before we are using that for any learning algorithm. So pre-processing makes the data clean, reliable, and suitable for artificial intelligence or machine learning models. So as an example of how the missing value is being filled out with the data, pre-processing is given here. So as we can see that the data recorded here is acceleration, strain, and temperature for the particular date. For every 1 hour it is being recorded. As we can see in the first 5 row, in the last row we can see that data is not available, and through the AI model or AI training the data is being filled out. So we can do the process of handling and finding the missing data with the help of AI algorithm, and we can filter out noise using signal processing methods, and we can remove irrelevant signals, sensor drift, or environmental interference if there is anything in the data, and those data can be removed, and the data which is required for AI model will be pre-processed. So next we'll see, next step in data pre-processing will be normalization and scaling. As we see, know that sensors measure different parameters with different units. We can see that strain will be obtained in microstrain, acceleration will be obtained in a different unit, displacement in different unit. So all these data are in different unit. So many AI models generally perform better when the input features are scaled to similar ranges. So in order to scale the input features to similar ranges, we are using normalization and standardization. So normalization is done where the data will be made to range from 0 to 1, and standardization will be done where the data will be ranged to the mean and 0 and standard deviation as 1. And as given in the figure here, the normalized SHM data is given for acceleration, strain, and temperature, where the data value is ranged from 0 to 1. So after data pre-processing, we need to do feature extraction, where we are reducing the data size and we are retaining only the useful information which are required for learning process. And these extracted features are helpful for prediction. And in order to reduce the dimensionality of the data which is being collected, we will be using techniques like principal component analysis, where the correlated features will be combined into the smaller sets of principal components. And autoencoders are also used to compress the data into the compact representation. So for example, if you see that the data collected from your bridge will be having 100 plus data sensor readings. So what are the key components which are required will be reduced with the help of the techniques like PCA and autoencoders, and that data will be helpful for damage classification. So after pre-processing data, we need to do the damage reduction. So like damage reduction can be done based on the data which has been collected till now and the data which has been processed. So here as an example, I have shown how the data which is collected related to amplitude and frequency is used to classify the structure as healthy or damaged. So damage makes the structure weaker and more flexible, causing lower frequency and higher vibration response. And here K-mean clustering is a machine learning technique which is used here to identify the condition of the structure, that is whether it is healthy or damaged condition. And this K-mean clustering is an unsupervised learning algorithm, and we are able to classify the health condition of the structure. And the AI models other which are used are machine learning techniques can be used, ANN and CNN techniques can be used to classify the condition of the structure. And we can even detect the early stage cracks which are not visible during inspection stage. So if this AI is used along with the acoustic emission sensors, we will be able to detect the crack initiation in the steel beams at the earlier stages. So next we'll see how the structural health monitoring can be done as predictive maintenance using AI techniques. Instead of only detecting current damage, AI models can also predict the degradation in the future. And the models which are trained using past data and field sensor data will be predicting the future damage or deterioration. And instead of doing the maintenance or repair work after failure, we will be able to do the predictive maintenance before the occurrence of failure in the structure. Till now, we have seen how the AI techniques can be used in the application of structural health monitoring, like processing of data, normalization of data, and predicting the damage reduction or predicting the deterioration of the structure in the future. And this slide shows the future of infrastructure. By combining AI, sensors, and digital twin, structure can monitor themselves, predict risk, and support proactive maintenance. And this leads to safer and smarter cities. And integration of this structure with a digital twin will be able to predict the performance of the structure under future earthquake or under heavy future traffic condition or future predicted wind load, where we will be able to identify the condition of the structure before the occurrence of the failure. Thank you and see you in the next video.